Hello, my name is Birring and today's lecture is on detection of hydrogen damage in boiler tubes, and this is actually in the power plants. So we are not talking about petrochemical plants here, we are talking about the power plants and the hydrogen damage in the boiler tubes. So hydrogen damage in the boiler tubes occurs, okay, first of all I have to say that under normal operating conditions this should not happen. It only happens when the pH level of the water drops to the acidic levels, which are actually below 7. So when the water becomes acidic and there is an upset in the water chemistry, then it happens, and it happens very rapidly. So it should not happen, but if the water chemistry there is upset, then it will happen. What does it do? It actually results in ID corrosion of the boiler tubes, and then it also results in decarbonization. And when this gets extensive, then it will lead to a failure of the boiler tubes. So again, to say that again, under normal conditions, under normal operating conditions, it should not happen. So what happens is that in the this is a cross section of a tube, and when hydrogen damage occurs, you will have corrosion on the ID like shown here, and there will be decarbonization also on here. And when this thing gets extensive, then it will result in a boiler tube failure. So let me also show you a sample of some boiler tubes with actual hydrogen damage. So these are cutouts from here, and you can see here there is actually corrosion on the ID, and there is decarbonization, which we can see by etching on the right here next to the corrosion. So here, and here is another tube, something like that, and you can see the corrosion here, and then there is another one here. So this is more extensive, and again there is corrosion and decarbonization. In order to see the decarbonization, you have to cut the tube and etch it, and you will see a discoloration. That will mean that there is decarbonization. So that's how it happens. And so where does it happen? So it doesn't happen all over the boiler. It only happens in very specific locations. These are the locations with the high heat flux in the boiler. It happens in the vents, and it happens at the circumferential wells, which are actually the locations of flow interruption. So those are the specific locations where it actually happens. So it doesn't happen all over the boiler. So now I'm just showing you like a boiler here, and I just kind of opened up the walls. So if this is the south wall, and this is the wall, west wall, which has the burners, and it will happen, hydrogen damage will happen on the wall which is across the burner wall. So this is the west wall. It will actually happen on the east wall, and that's how it will happen. And that's where you will see if it gets extensive, then you will start seeing the tubes to start to fail. So they are not going to fail at the same time. It will pop up, one will pop up, it will fail, and then you repair it, and then the next one will fail, like that. So this is where it happens. So in order to do this inspection, it's a very targeted inspection. First of all, you only do this inspection only if you have already had a hydrogen damage failure, and you have verified the hydrogen damage by cutting the tube and sectioning it just the way I showed you, those 3 tube samples. You have to make sure that the damage or the failure was caused by hydrogen damage. And once you verify that, then you can actually apply the ultrasonic technique, which I will actually demonstrate to you in the next video on how to do the inspection and detect the locations of the hydrogen damage in these boiler tubes. So it's a very specific way to do it, and we will discuss in part 2 of this topic. Thank you.